Students, welcome to Saurav Sir's classes. This video is in finite series part 10. We will start this video with logarithmic test. It states that if summation un is a positive term series, such that limit n tends to infinity, n log un divided by un plus 1 is equals to k, then if k is greater than 1, then the series is convergent. And if k is less than 1, then the series is divergent. Now let us prove it. Case 1, that is when k is greater than 1. Now we can choose some p, let p be such that k is greater than p is greater than 1, and we compare summation un with series summation 1 by n raised to the power p, which is convergent since p is greater than 1. Therefore, summation un will converge if from and after some terms un by un plus 1 is greater than n plus 1 raised to the power p by n raised to the power p, which is equals to 1 plus 1 by n raised to the power p. Or if un by un plus 1 is greater than 1 plus 1 by n raised to the power p. Or if log of un by un plus 1 is greater than p log 1 plus 1 by n. Now log of 1 plus x is equals to x minus x squared by 2 plus x cubed by 3 minus x raised to the power 4 by 4 plus and so on. So un will converge if log un by un plus 1 is greater than p into 1 by n minus 1 by 2n square plus 1 by 3n cube minus 1 by 4n raised to the power 4 and so on. Or if n log un by un plus 1 is greater than p into 1 minus 1 by 2n plus 1 by 3n square minus 1 by 4n cube plus so on. Or if limit n tends to infinity, n log un by un plus 1 is greater than p into limit n tends to infinity 1 minus 1 by 2n plus 1 by 3n square minus and so on. Or if k is greater than p, which is true, as our k is greater than p is greater than 1. Hence summation un is convergent. Similarly, when p is less than 1, when k is less than 1, using the similar steps as in case 1, we can prove that summation un is divergent. So this is the proof of logarithmic test. Note that when k is equals to 1, that is limit n tends to infinity n log un by un plus 1, when this is equals to 1, then the test fails. The logarithmic test fails. Next is Cauchy's root test. It states that if summation un is positive term series, such that limit n tends to infinity un raised to the power 1 by n is equals to k, then if k is less than 1, the series converges. And if k is greater than 1, then the series diverges. Let us prove it. For case 1, that is when k is less than 1, we can find a positive number r. Let r be such that k is less than r is less than 1, such that un raised to the power 1 by n is less than r for all n greater than m, where m is some particular term. Or un is less than r raised to the power n for all n greater than m. Now since r is less than 1, therefore limit n tends to infinity r raised to the power n is equals to 0, or this implies limit n tends to infinity r plus r square plus so on till rn, which is equals to limit n tends to infinity 1 minus r raised to the power n divided by 1 minus r. This is equals to 1 divided by 1 minus r, that is a finite. So this implies limit n tends to infinity u1 plus u2 plus so on till un tends to is less than 1 divided by 1 minus r, which is a finite quantity. Hence, summation un is convergent. Next, if k is greater than 1, then we have un raised to the power 1 by n is greater than 1 for all n greater than m, where m is some particular term. Or un is greater than 1 for all n greater than m. Then the series summation un be u1 plus u2 plus u3 plus so on, so that u1 is greater than 1, u2 is greater than 1. Continue. Then this implies that u1 plus u2 plus so on till plus un is greater than n, or limit n tends to infinity u1 plus u2 plus so on till un is greater than limit n tends to infinity n, or limit n tends to infinity u1 plus u2 plus so on till un tends to infinity as limit n tends to infinity, and this part tends to infinity. Hence, summation un is divergent. Thus we have proved the Cauchy root test. Note that Cauchy root test fails when k is equals to 1. Cauchy's root test fails when k is equals to 1. That is, when limit n tends to infinity un raised to the power 1 by n is equals to 1. Then the Cauchy root test fails.